You may have noticed we're skipping 5.5. That's because 5.5 is a lesson that we've already kind of covered, and we don't have time to cover it again. So we're going to skip on to 5.6.
Because why do we keep doing work? We only have like 11 days left.
Oh my goodness.
So 5.6, graphing linear inequalities in two variables. We ready to begin?
Yes.
Ready or not, here it comes. A linear inequality in two variables, x and y, can be written as ax plus by is less than c, ax plus by is less than or equal to c, ax plus by is greater than c, ax plus by is greater than or equal to c. Those are our four inequality symbols, where a, b, and c are all real numbers. A solution of a linear inequality in two variables is an ordered pair, x comma y, that makes the inequality true. So, whenever we have a graph of a linear equation, there's ordered pairs on that line, correct? Does everyone agree with that statement? So, the ordered pairs on that line of a linear equation all make the equation true. They're all solutions of that equation. That's what that line is representing. It's representing all the solutions of that linear equation. Similarly, there's ordered pairs that make our inequalities true as well. So we've graphed linear equations before. It's going to look kind of similar today, graphing the inequalities, but there are definitely some differences when we're graphing them. And we'll look at those here in a second. Can I move on?
No.
Okay, I'm waiting. Caden, you writing? No, you're not. Don't lie to me. Don't lie to me.
Not lying. Just saying in my head.
Okay, moving on. Here's our first example. Checking solutions. It says tell whether the ordered pair is a solution of the inequality. So it gives me an inequality, and it gives me an ordered pair, and it wants me to check to see if that ordered pair is a solution. How do I check to see if it's a solution? Plug what in for what?
Oh, x for, well, -1 for x, 9 for y.
Very good. My ordered pair is an x value and a y value, so I just plugged them into their respective spots. So I'm replacing the x. What do we say our x value was? Replacing the x with -1. What's my y value? 9. So replace the y with 9. It's less than -3. So now I'm just going to work down both sides of my inequality, see if I get a true or false statement. What's 2 times -1? -2. So I get -2 plus 9 is less than -3. What's -2 plus 9? 7. So I get the statement 7 is less than -3. Is that a true or false statement?
False.
False. So would this ordered pair be a solution to this inequality or not?
No.
No. So I'd say it is not a solution. The ordered pair is not a solution. The ordered pair -1, 9 is not a solution. Something along those lines.
Should we put like no solution?
No. I was actually about to say that. Do not put no solution or the symbol for no solution, because there is a solution for this inequality. I'm just saying that this ordered pair is not a solution. Does that make sense? It does have a solution, it's just not this specific ordered pair. Questions on A? Okay, let's do the same thing for B. Gives me a different inequality and a different ordered pair. But I'm doing the same thing as I did on my previous example. What's my x value?
2.
So replace the x with 2. Minus 3 times y. What's my y value?
-2.
Replace the y with -2. Greater than or equal to 8. Any questions on how I'm plugging in? What comes first in an ordered pair, an x value or a y value? Always an x value. It's always x comma y. It's never y comma x. What's negative 3 times negative 2?
6.
Positive 6. Greater than or equal to 8. 2 plus 6?
8.
So it gives me the statement, 8 is greater than or equal to 8. Is that a true or false statement? True. It just has to meet one of those conditions, greater than or equal to. 8 does equal 8, right? So like we said, it is a true statement. So is this ordered pair solution?
Yes.
Yes, it is. So I'd say it is. A solution. Any questions on example 1? Everyone good with that? Not too bad on checking solutions. Can I move on? Okay, let's talk about graphing linear inequalities in two variables. The graph of a linear inequality in two variables shows all the solutions of the inequality in the coordinate plane. Just like when we graph a linear equation that shows all my solutions of that equation. My inequality does the same thing. It shows all my solutions of that specific inequality. So here we have a little example. This is the inequality y is less than 2x. It says all solutions of y is less than 2x lie on one side of the boundary line y equals 2x. So, this is how it's similar to graphing an equation. If I have an inequality, I can graph it like it was an equation. So what's my y-intercept here in this case? 0. There it is. There's my y-intercept is 0. What's my slope? 2 over 1. So our y-intercept was 0, 0. Slope was 2 over 1. So which directions am I going?
Up 2, right 1.
So up 2, right 1. Up 2, right 1. Does everyone see how they got their graph? So it's graphing essentially the same way we did with our linear equations. However, you might notice that it's a dashed line instead of a solid line. We're going to get to that here in a second. So that forms our boundary line. The boundary line divides the coordinate plane into two half planes. So it cuts the coordinate plane into a half. Here's one half. Here's the other half on the other side of it. The shaded half plane is the graph of y is less than 2x. So every ordered pair in this shaded region is a solution to my inequality. So we're used to, with the equation, the line being my solution. Here, the shaded area is my solution of my inequality. Does that make sense? And we're going to learn how to shade and how to graph these here in just a second. But does that make sense? So once again, my solution is not just the line. It's the shaded area either above or below the line. Everyone good with that? Any questions? Can I move on? So here's some steps for graphing a linear inequality in two variables. Step 1, you want to graph the boundary line for the inequality. So once again, use your slope and your y-intercept. Graph your y-intercept, use your slope to get more points. Here's where the dashed line, solid line comes into play. Use a dashed line for less than or greater than. Use a solid line for less than or equal to, or greater than or equal to. My general rule of thumb, if it has a line under it, you're using a solid line. If it does not have a line under it, you're using a dashed line. Does that make sense? It's very similar to the open dot, closed dot principle whenever you're graphing inequalities on a number line. You guys remember that?
Yes.
If it has a line, it's a closed dot. If it has a line, it's a closed line. It's a solid line. It's an open dot, or if it doesn't have a line, it's an open dot. If it doesn't have a line, it's an open line, dashed line. And it means pretty much the same thing. If I have a solid line, it means the ordered pairs on that line are a part of my solution. If it has a dashed line, the ordered pairs on that line are not a part of my solution. Does that make sense? Step 2. Test a point that is not on the boundary line to determine whether it is a solution of the inequality. Step 3. When the test point is a solution, shade the half plane that contains the point. When the test point is not a solution, shade the half plane that does not contain the point. So, what it's saying is pick a point, an ordered pair that's not on your boundary line. A lot of the times, if 0, 0 is not on your boundary line, 0, 0 is a good thing to plug in. It's always easy to plug in 0. But you plug it in. If it makes the inequality true, shade the area where the test point is. If it makes it false, shade the area opposite of that test point. Does that make sense? I will show you another method of shading whenever we get to our example. Because I do not shade like this. I shade a different way. Are there any questions about any of my steps for graphing a linear inequality? Am I good to move on?
No.
Okay, I'm waiting. Am I good to go on? Huh?
I'm still looking.
Still writing? Okay.
Sorry.
You're good. Okay, I can always come back to this slide if I need to. I'm going to move on though. Example 2, we're going to graph a linear inequality in one variable first, and then we'll get one in two variables. So graph y is less than or equal to 2 in a coordinate plane. So remember, we want to first graph like we normally do, and don't worry about the inequality symbol for now. So we're graphing y equals 2 pretty much. Does anyone remember how to graph a line with just one variable?
It's just straight across or straight up, right?
Yes, which one though? Is it this one in this case?
Just straight across like that.
No, it's up.
So is it horizontal or vertical?
Why, it's a horizontal.
It's horizontal. I agree with that. It's horizontal. You guys remember Hooyvuks? If it contains a y, it's hoy. If it contains an x, it's vux. So does this contain a y or an x? Y, so this is hoy. So the y on hoy tells me it's crossing which axis?
Y.
It's crossing the y-axis. Where's it crossing the y-axis? At 2. So I'm going to put a point at 2 on my y-axis. Okay. What does the H on hoy stand for? Horizontal. So it's a horizontal line going through that point. And we are dealing with inequalities now. So I need to decide if it's a solid line or a dashed line. So what is it in this case?
Solid.
Why is it solid? It has it's less than or equal to. It's got that line under it. So I know it's a solid line. That means all the points on this line are included in the solution for this inequality. Everyone agree with my line? There's my boundary line. Now I've got to decide on the shading. So remember it said to pick a test point that is not on the line. Like I said, I like to use 0, 0 if it's not on the line, because 0 is easy to plug in. If I have the ordered pair 0, 0, what am I going to plug in from my y into my inequality? So we're using the test point 0, 0. The y value is 0, so I get 0 is less than or equal to 2. Is that a true or false statement?
True.
True. So here's 0, 0, right? Since it made a true statement, I need to shade the side that test point is on. So I'm shading this side of my boundary line. Does that make sense?
How do you get the test point again?
You get to pick the test point. Just any point that's not on this line. So you could have picked 0, 5. If I would have picked the ordered pair, 0, comma 5, right there, what would I have plugged in for y? 5. When I plug in 5, does that give me a true or false statement? False. So if I were to use that as my test point, I would know that I need to shade it the opposite side of the boundary line, because that's not a solution.
So only use the y coordinate for the test point.
If it's like this. If it's y is less than, greater than a number. If there was an x and y in there, I'd have to plug both points in, or both values.
Okay. Is that going to be
But-
one of our examples?
Yeah, we're going to see one like that. So if this was x is less than or equal to 2, what would I plug in for x? 0 or 0. Does everyone see how we use a test point to shade our graph? Does that make sense how we do it? If your test point gives you a true statement, you're shading that side of the boundary line. If the test point gives you a false statement, you're shading the opposite side of the boundary line. You guys ready to find out how I shade? Okay. So how I shade is I look at the inequality symbol. What I first do is I first make sure y is on the left side of my inequality. Is that the case here? Y is on the left-hand side. This only works if y is by itself on the left-hand side. Since y is by itself on the left-hand side, I look at my inequality symbol. What's my inequality symbol? Less than or equal to. Less than tells me that y is less than my line. So I'm shading less than my line, so below it. If that was y is greater than or equal to 2, that'd be y is greater than my line. So I'd shade above it. Does that make sense? That's how I shade. Okay, so there's two ways right there. Questions on example 2?
No.
Can I move on?
Yes.
Sweet. Here we go. Here's an example with two variables. Graph negative x plus 2y is greater than 2 in a coordinate plane. What's the easiest way to graph a line? What form? Slope intercept. I would agree with that. So what do I need to solve for here? I need to get y by itself. What would be my first step to do that? Add x to both sides. 2y is greater than x plus 2. How do I get y by itself now? Divide by 2. So y is greater than x over 2 also means 1/2 x. And what's 2 over 2? 1. So I'm graphing this inequality. Is that now in slope-intercept form? Yes, it is. Now let me remind you of something. Be very, very, very careful of this. When you're solving for y, does anyone remember what happens when you multiply or divide both sides of an inequality by a negative number? Very good. My inequality symbol flips. So if this was a negative 2 in front of my y value, and I divided by negative 2 on both sides, this inequality symbol would have to flip. Do not forget about that concept. That still is in play.
So only when it's negative though?
Yes, anytime you multiply or divide by a negative, that's it. Anytime you add or subtract, it stays the same. Only if you multiply or divide. You may want to write that down. If you multiply or divide both sides of the inequality by a negative, your inequality symbol flips. If you multiply or divide both sides of an inequality by a negative number, the inequality symbol flips. Luckily, it didn't flip on us in this case. What's my y-intercept here?
1.
1. So I'm putting a point at 1 on my y-axis. What's my slope?
1/2.
1/2. So which two directions am I going?
Up 1 to the right 2.
Up 1, right 2. I just keep doing that until I run out of graph.
And then you go
Up 1, right 2. What other two directions can I go?
down 1, left 2.
I can change the sign of both of them and go down 1, left 2. So there's the guide for my boundary line. Is this going to be a dashed or solid line?
Dash.
Why is it dashed?
Because it's an open look.
There's no line underneath my inequality symbol. It's not greater than or equal to, it's just greater than. So I know it's going to be dashed. So how you do a dashed line, you just do a bunch of dashes. Like so. You still need your arrows though, because it does still go on forever and ever and ever. Questions on how I got my line, my boundary line?
No.
Okay? Let's go ahead and use my method real quick of shading. Is my y on the left-hand side of my inequality by itself? Yes, it is. So I can use my method. It says y is greater than 1/2 x plus 1. So greater than, is that telling me to shade above my line or below it? Above it. It's telling me to shade greater than my line. So that'll be this section up here. And you don't have to like color in the whole graph. Okay, if you just kind of scribble it in like that. Okay? Let's say you like using the test point. Which test? Someone raise your hand and give me a test point. That's not on my line.
0, 5.
What?
It says 0,
0,
0.
0. So I'd plug 0 in for y, 0 in for x. What's 1/2 times 0? What's 0 plus 1? Is 0 greater than 1? No. So here is 0, 0. When I plugged in 0, 0, it gave me a false statement, correct? So I know I needed to shade the opposite side of the boundary line. Does that make sense? Any questions there? Not too bad? That'd be my graph right there. Can I move on? Here we go. My last example. You can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound, and apples cost $1 per pound. Write and graph an inequality that represents the amounts of grapes and apples you can buy. Identify and interpret two solutions of the inequality. Any idea how I'm going to set this up?
No.
I think it should be 250x.
Okay.
No, 2.50x. Plus 1y equals, well, is greater than or equal to 10.
Does everyone agree with them? Huh?
Oh, hold on. Yeah, it needs to be less than or equal to. Sorry. My bad.
Does everyone see why it has to be less than or equal to?
Yeah, because it says at most.
It says I can spend at most $10. So can I go greater than $10? I cannot go above $10 because it says at most. So it has to be anything less than. And at most can equal 10, so it's less than or equal to. Does everyone see how we got the left part of the inequality? 2.50x plus 1y. So x is representing the pound of grapes that I buy. Y is representing the number of pounds of apples that I buy. So $2.50 per pound of grapes, $1 per pound of apples. Has to be less than or equal to $10. Questions there? So to graph this, let's go ahead and get it in slope-intercept form. What would be my step to get y by itself? Subtract 2.50x. So I get y. Does my symbol flip or stay the same?
Stay the same.
Stays the same. I just subtracted, so we're good. I'm just going to write 2.5. Everyone okay with that? There's my inequality. Now it tells me to graph it. For our slope purposes, what's negative 2.5 as a fraction? as an improper fraction?
Oh.
That's a good question, dude.
It would be that.
Everyone agree with that? So what's my y-intercept?
10.
Put a point at 10 on my y-axis. We said our slope was negative 5 over 2. So what two directions am I going?
Down 5 left, 2.
1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2.
Why are you doing right?
Yeah, why are you doing
Huh?
Because it's a positive.
Remember, the negative only goes with one in my numerator or my denominator, not both of them.
Can I redo my rule?
1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. Is this a solid or dashed line? It is solid.
Solid.
So here is my boundary line. You can use either method of shading you want. Which method do we want to use here?
Yours.
My method.
McAllister.
So is my y on the left-hand side by itself?
Yeah.
Yes, so my method will work. It's less than, so am I shading above or below my line? Below.
Or to the left. Well, they could be below the line.
I have a question.
Yes.
Say the line was going straight up and down. Would we shade like to the left of it?
So if it's straight up and down, if it's a vertical line, that's a good question. So let's say it's like x is greater than 2. Greater than would be to the right of my line. Because remember, our x-axis goes from negatives to positives, right? So I want my x value to be greater than 2. So it's going to be all the numbers that are bigger than 2. So less than will be to the left because it's the numbers less than that number. Does that make sense?
Yeah.
Okay. Everyone okay with my shading?
Yeah.
Okay. Let's think about the context of this situation. We're talking about, what was our x value, or our x variable? What did that x stand for? The pounds of grapes. What does my y stand for? Pounds of apples. So we got pounds of apples here, pounds of grapes. Am I ever going to have negative poundage of grapes or apples? No. So for this specific situation, I'm only looking at my first quadrant. Because that's all my positive values. Does everyone understand that concept? So, the next thing it asks me to do is identify and interpret two solutions of the inequality. So someone raise your hand and give me one solution. I've got a lot of solutions, but give me one of them.
I'd say two pounds of grapes and 30 pounds of
2, 3.
2 and 2.
Is 2, 3 in my shaded area? Yes, it is. So it is a solution. That means I can buy 2 pounds of grapes, 3 pounds of apples, and that would either be less than 10 or equal to 10. Everyone got that? Someone raise your hand and give me another solution. 1, 6.
Yeah.
Is 1, 6 in my shaded area? Yes, it is. So I can buy 1 pound of grapes, 6 pounds of apples, and that'll be either less than $10 or equal to $10. What if I pick the ordered pair 2, 5?
Yeah. Good question.
Where is 2, 5?
No, it's right on the line.
It's on my line. Is my line solid or dashed?
It's
Solid.
So it is.
If my line is solid, it includes the ordered pairs on that line.
Oh, because it's
It's equal to, yep. If it's dashed, it does not include those ordered pairs on that line. Does that make sense? So 2, 5 would work here. Any questions, comments, concerns?
Yeah.
Can I move on?
Yes.
Here we go. Pages 261 through 262, numbers 4 through 38, evens. This is due on Friday, May 14th. On Canvas. Any questions before I end the recording?